Okay, here's the reaction that we're going to be doing. It looks kind of simple, but it's a little deceptive. Basically, you take a solution of 0.1 molar sodium sulfate. We're going to add a little bit of acid to it, which really acts like a catalyst. It's going to create solid sulfur and SO2, which is a gas, and sodium chloride. Right away, you think, hey, that's going to smell bad, but this is why we're doing it on a microscale. And this is a rate study. What's going to make this speed up and slow down and go faster? Now, it looks like it's simple, but really, we think we have all of these reactions going on. And this is crazy, right? That this thiosulfate reacts with the acid, and then we have some what appears to be sulfur attaches to this thiosulfate, and you've got all this weird stuff going on. And we think that this is what occurs, and eventually we're getting these long strands, and N is just a word for some number. It's not, this does not mean 10. So this means like some number of these thiosulfates, and there's some amount of N, and eventually there's like a little equilibrium here, and there's an acid, and it cleaves off to form S8, or sulfur, really, and that's what we can actually detect, okay? So the question is, well, what's the rate determining step? And how can we make this thing go faster and slower, and what's going to affect the rate of a reaction? So how are we going to do this? Well, here's the setup that I have here. A couple points. First thing you want to do is take some drops of sodium sulfate, and each drop will be considered a volume. Like, almost kind of like a milliliter. We'll have some water and some HCl, and we'll record the right amount. So we've got these dropper bottles, and it turns out I've got some setup right here. Now, it turns out that what I have here is I have where one of them is just sodium thiosulfate. One of them is sodium thiosulfate with water, so it's a little less concentrated than the other one. I'm not going to tell you which one. I have a clock here, which is very important. And then now we're going to add the acid to get it going. And I'm putting in 2 drops of acid.
Julie Tyre, please call.
Pardon the interruption.
3216. Thank
okay.
you.
So this is kind of a cool reaction. Now, first of all, I have to give credit where credit's due. This is done by Bob Worley from Cleeps in England, and also Flynn Scientific does a version of this, so I kind of tried to make it a microscale. It's a little bit different in that what I'm doing is I'm using a camera and a clock, because what we're going to see slowly as the sulfur starts to form, after a while, you're not going to be able to see the little plus sign there. And if we only depend on our own eyes, it's going to make it really, really hard to be able to figure out, to compare these. But the nice part about this, okay, is that this little watch right here gives me a time of when I started the HCl. So I have when it started. I can definitely see that it appears that, hey, this one is starting to react, okay, maybe a little more than this one, and we can sort of use this sort of as a comparison. That, it's hard to tell when we're being qualitative, but with this one, we can say, okay, this is definitely a full reaction, whether it is or isn't, and we can use these as sort of like a comparison. And we have a time here as well. And so when they, this will tell us when the reaction essentially goes to completion. And our goal is to try and get some data and figure out, okay, which is going to react faster, which is going to react slower. And you can see now, it looks like that the one on the left probably is a little bit faster than the one on the right. And then the nice thing about having this as a video, you can replay it and say, okay, when did they look the same? Okay, so at how much time lapse, and then we can, if we can try and be consistent each time, and saying, okay, when did the two look the exact same? At what time did it happen? And if you're not sure, you can always play again. So here's your question for you. What happens if we have different concentrations of thiosulfate? Do the experiment. What happens if we try and find a catalyst? Like, does acid act as a catalyst? Do the experiment. Would copper act as a catalyst? Try the experiment. What if we heat it up or cool it down? Design the experiment. Again, it's dropwise. Now, the other nice thing is sulfur compounds smell horrible. And with this one, if we create much SO2 or where it starts to smell bad, we take a little bit of sodium carbonate or calcium carbonate and dump it in there. Essentially, it's a little bit of a Tums or a piece of chalk. That's all it is. It'll quench it to form like a calcium sulfate, and we're pretty much done. And so you can actually use your video as an analysis to say, okay, at what point in this reaction, how long did it take, and can we do it, and can we compare it with other groups as well? And that's the way that hopefully we're going to study these rates.